Which of the following carbocations is the most stable? So we need to remember what stabilizes a carbocation. So carbocations are more stable if they are more substituted. And if they're more substituted, what they're really being stabilized by is hyperconjugation. So we are looking here for a more substituted carbon atom. Another thing that can stabilize carbocations, besides hyperconjugation, is delocalization. So that means if you have a resonance stabilized carbocation, it will be more stable than one that is not. So if we look at the first carbocation, so here is our carbocation, and this has 1, 2, 3 bonds to carbon, so this is a tertiary carbocation. So that should be relatively stable. If we look at the next one and we look at that carbon that has the positive charge, this positive charge is on the sp2 hybridized carbon. It might be tempting to think of this as resonance stabilized, but we want to be careful that we're not confusing this vinylic cation with a cation at the adjacent carbon, which would be allylic and resonance stabilized. So this is a vinyl cation, and this is not stable. If we look at the next option, we have a carbocation at the end of the chain. We have only 1 bond to carbon, so this is a primary cation. And finally, if we look at the last option, we have a carbon here that has the positive charge. It has 1, 2, 3 bonds to carbon, so this is a tertiary cation. So at first glance, we might think that A and D have the same stability, but in D, we also have this allylic pi bond. So not only is this a tertiary cation, this is a tertiary allylic cation. And so that extra resonance stabilization will make this tertiary cation even more stable than the one in A.